We're going to find the inflection points for f of x equals ln of 1 divided by ax, and the whole thing is squared. The first thing we're going to do is rewrite this. Let's write this with y. So I'm going to write this as y equals ln, and I'm going to bring this ax up here. So ax to the power of negative 1, and then square it like that. Then I'm going to use my power property for logs. Write this as equal to negative ln of ax, and then the whole thing is squared. Now when you square a negative, this is going to go away. So now we can simplify this and write this as ln of ax squared. So now let's differentiate this. We're going to do y prime equals, and when you differentiate this, we're using the chain rule. So this is going to be 2 times ln of ax times the derivative of the inner function, which is 1 divided by ax. Then you have to differentiate this part, which is just going to be the derivative of ax is just a. All right. So if you simplify this, we're going to get 2 ln of ax all divided by x, because these a's will cancel here. All right. Now let's go ahead and differentiate the second time so we can find the inflection points. So when you differentiate again, we're going to have to use the quotient rule. So we're going to take our numerator, and differentiate this. So this is going to be 2 times 1 divided by ax times your inner function, which is a times x. All right, and then you minus, and we're going to copy down 2 ln of ax, and then we're going to differentiate the denominator, which is 1. And this one, it was the x for the denominator. And then you square the denominator, so x squared. This simplifies to that these two are just going to cancel. So I can just factor out a 2. We're going to get 2, and this whole thing's going to be 1 minus ln of ax all divided by x squared. I'll put a little bracket here. Now, we want to see what happens when we set this to 0 to find the inflection points. So when you cross multiply, the x squared goes away. And I'm going to try to squeeze this in here a little bit. So basically, if I cross multiply, I'm going to, and if I divide both sides by 2, that's just going to give me 1 minus ln of ax equals 0. Again, you just divide both sides by 2, and when you cross multiply, that goes away. So we're only looking at this. So basically, we have ln of ax equals 1. And for that to happen, our ax must equal e, because ln of e is 1. Or we could say x equals e divided by a. All right. From there, we're going to find our inflection points. So let's look at that. If we have x is less, we're looking on the right and left-hand side of x equals e divided by a. So when x is less than e divided by a, that means 1 minus ln of ax is positive. Okay, so that means our second derivative is positive. When that happens, that means we're going to have a minimum value. And when x is greater than e divided by x, that means we're going to have 1 minus ln of ax is negative. And so that's going to give you your maximum. We're just looking for the inflection points. So basically, looking at your second derivative, since they have different signs, we have positive and negative on either side of e divided by a. That means e divided by a is an inflection point. If you substitute that in to the equation here, you're going to get 1. So if you just substitute e to the power of a here, that's going to give you 1. And that is your inflection point. Thank you. Have a nice day. Bye-bye.